Good afternoon, everyone. Thank you for choosing to come to this session about what's new in Windows Server 2019 for Hyper-Converged Infrastructure. My name is Cosmos Darwin. I'm a senior program manager on the Core OS engineering team at Microsoft. This is my first time coming to the Cloud and Data Center conference in Germany. And so normally, on a typical day like today, it's just barely Tuesday morning back in Seattle. I would be going to work in Seattle. And prior to that, I was born and raised in Canada. And one thing that both Seattle and Canada have in common is we speak English there. And unfortunately, sometimes we get it in our heads that it's the center of the world and we don't learn other languages. So I did want to say thank you for allowing me to conduct this presentation in English. Now, hyper-converged infrastructure is quickly becoming the way that organizations deploy on-premises server infrastructure. And we see this all the time, all the way from the smallest of scales to the largest. It's becoming essentially the normal way that folks, when it comes time for an infrastructure refresh, everybody is doing hyper-converged infrastructure. And by consolidating from sort of a traditional three-tier architecture to simply industry-standard x86 servers that sort of bring their own software-defined storage and software-defined networking, organizations around the world are really driving down costs, simplifying their operations, and increasing the performance that they can get out of their infrastructure. When I say it's becoming the normal way that people are doing things, in fact, recent data from the Enterprise Strategy Group shows that 54% of organizations who have a mature data center modernization strategy expect that deploying hyper-converged infrastructure is going to be among their most significant initiatives in the next year to year and a half. And that's not just aspirational talk. That's not just, organizations have high hopes or dreams of doing this. I mean, it's actually already happening. If you look at data from IDC, investment in hyper-converged infrastructure has actually been increasing very rapidly year over year. From just March of last year to March of this year, investment increased over 50%. It's now nearly $2 billion every quarter that people are spending on deploying hyper-converged infrastructure. That's a lot of investment, and it means actually a lot of opportunity for us in IT to really be a part of that change. So how do you go from Windows Server or Hyper-V, which you may already be familiar with, to a hyper-converged infrastructure? What's the easiest way to make that transition? And the answer is Windows Server 2019. Windows Server 2019 contains everything that you need to manage and deploy hyper-converged infrastructure, including, of course, Hyper-V, which, show of hands, who here is familiar with Hyper-V? There shouldn't be anyone in the room with their hands down. Yeah, that's what I thought. It includes Hyper-V, of course, but also two newer technologies that maybe you're a little less familiar with, namely software-defined storage in the form of Storage Spaces Direct, and also software-defined networking. All of these are just included in Windows Server 2019. Something else that's essentially included is Windows Admin Center, which is the future of Windows Server graphical management, and is available at no additional cost beyond your Windows licenses. As long as you have a Windows Server, you can manage it with Windows Admin Center for free. Windows Admin Center, I'll talk about it a little more in a minute, but it's the future of Windows Server management in terms of the inbox tooling. We have a very large engineering team back in Redmond committed to taking all of the tools that you're familiar with in Windows Server and essentially modernizing them in a way that's familiar, but better, more powerful, and natively sort of more graphically ambitious for the next generation of server management tools. Earlier this year, together with our partners, Microsoft announced something called the Azure Stack HCI solutions. And what an Azure Stack HCI solution is it combines everything I just talked about, Hyper-V, Storage Spaces Direct, and software-defined networking in Windows Server 2019 with Windows Admin Center to manage it, installed on pre-validated hardware offers from our partners. If you run that software on a pre-validated piece of hardware, that's what we call an Azure Stack HCI solution. So if it's just Windows Server 2019, why is it called an Azure Stack HCI solution? Well, there's two reasons, one good reason, one less good reason. The less good reason is our marketing people really prefer that, if we call it Azure. The other reason, though, which makes a little more sense, is another way to think about what an Azure Stack HCI solution is that it's the same hyper-converged compute, storage, and networking infrastructure running on the same hardware with the same hardware validation criteria and testing as a full Azure Stack. It's the same bottom two layers, but instead of being geared toward Azure consistent IaaS and PaaS with a consistent portal and consistent APIs, instead of being geared toward that, it's a more familiar way to run virtualized apps on premises. You can use any capable tool. You have full admin rights to the box. It's a much more familiar way if you're coming from a Windows Server background, but still giving you that same hyper-converged infrastructure that Azure Stack runs on. So that's what Azure Stack HCI solutions are. So I'll be giving 4 different talks here at CDC Germany over the next 2 days. The next 3 are going to be covering Storage Spaces Direct in somewhat more depth. And so if you're interested in sort of a deep, gory assessment of how Storage Spaces Direct actually works, I'll be getting more into that in the next 3 talks. For this one, this morning, the topic is what's new in Windows Server 2019. And so I thought probably the cleanest way to do that would be to pick a few things that stand out to me that I think really make Windows Server 2019 the best for hyper-converged infrastructure, and then to talk about those. And so I picked 10, and I'm hoping that in the next however many minutes I have left, about 40 minutes, we'll be able to get through that top 10. Does that seem like a good plan? Everyone's clear? Awesome. Let's get started then. It's impossible to talk about hyper-converged infrastructure in Windows Server without talking about the most obvious new thing, and that's Windows Admin Center. As I said, it's the future of Windows Server management. It's where all of our engineering effort for graphical user interfaces, or UIs, is going. And that's certainly true for hyper-converged infrastructure as well. In fact, there are a dedicated set of screens in Windows Admin Center that all they do is help you to manage Storage Spaces Direct, software-defined networking, and Hyper-V. And it's actually surprisingly easy. If you haven't taken a look at storage spaces in a few years, it's surprisingly easy how quickly you can, with Windows Admin Center, do things like provision, expand, or manage your storage volumes. Or take a look at storage jobs, like a repair or a resync. You can see it right across the top of the screen there. There's also this wonderful view of your virtual machines across an entire cluster. And so you can easily see all the VMs, regardless of which host server they're running on. And you can see their resource consumption very easily in this one nice at-a-glance list. And you can even dive into things like hardware troubleshooting. So there's some really powerful visualizations in there around drive latency, finding drive outliers, finding drives that are having read or write errors, and you can actually see it directly in the UI. And so it's a really quite a powerful and well-rounded set of tools for managing hyper-converged infrastructure. And all of the feedback that we get on the engineering team related to Hyper-V Manager or Failover Cluster Manager, and we do get feedback about those tools all the time. All of that feedback, we're taking it, and we're not going and changing the legacy Hyper-V Manager, though. What we're doing is putting all of that feedback into Windows Admin Center. So as you can see across the bottom, it works with many different versions of Windows Server. The hyper-converged infrastructure tools specifically work with Windows Server 2016 and 2019. There are actually other parts of Windows Admin Center which extend much further back to Windows Server 2012 R2, 2012, and even in a few cases to 2008 R2. You can download it. It's like 50 megabytes. Show of hands, who is already using Windows Admin Center? Oh, most of the room. Good. Then you know that you can download it and get started in just a very few minutes. And if for those of you who, I won't do the reverse. I won't make those of you who haven't put your hands up, but you know who you are. You can go to aka.ms/Windows Admin Center and get started right away. So I will skip through these FAQs since it seems like most of the room is already pretty familiar, right? It takes just a few minutes to install. It's no additional cost. You don't need to set up a database. It doesn't have a dependency on System Center. And it also doesn't need an internet connection, which means it doesn't require an Azure account. There's no a hidden hook there. You just download it and you're off and running. Something else that's really important about Windows Admin Center is it's not just a platform for us as Microsoft to deliver our new first-party UI for things like Hyper-V or storage spaces. It's also an extensible platform. So all of the controls, for example, I showed a bunch of pictures there that had nice charts. All of those controls are available through a software development kit for third parties, hardware vendors and software vendors and apps, to extend and build their next generation of server management UI in Windows Admin Center. And there are a number of hardware partners in the hallway outside, like Thomas Kren or Dataon or Lenovo or Fujitsu or Dell, who have actually built extensions to Windows Admin Center that allow you to get deep visibility into their, in this case, hardware, but there are also software vendors doing the same thing, from within that same single pane of glass. And if you think about hyper-converged infrastructure as kind of an integrated hardware-software system, this is a really big deal, because it means you're not just getting Hyper-V Manager. You're getting Hyper-V Manager with the storage integrated, with the clustering integrated, with the hardware management integrated, all in one view, which is a really big deal. So when we launched Storage Spaces Direct in Windows Server 2016, the number one piece of feedback we got was, hey, you guys need to build a decent graphical user interface for this thing. And so that's what Windows Admin Center was our answer to. The number two piece of feedback, the next most requested thing, was for deduplication and compression. Deduplication and compression is the technology in Windows Server that saves you space by identifying duplicate portions of files and then only storing them one time. So the savings that you get depends on the type of files that you're storing. So on the one end, files that are already very well compressed, like video files or audio or pictures, typically the savings rates there are only around 30% because they're not very duplicative to begin with. But as you start to move toward a general purpose file server, or in the best case, things like VHD archives or backups of your ISO files, those kinds of things, which can be very, very repetitive on disk, we sometimes see savings rates up to about 90%, which, to put that in perspective, 90% capacity savings from data deduplication means you're getting about 10 times more usable storage just for turning this feature on. And in fact, at Microsoft Ignite in the fall, I gave a demonstration where we took the real files of the Microsoft Edge engineering team, where they run all of their testing on top of HCI, and we just took the files, turned on deduplication, and then came back in the morning, and it had been compressed down. They had 89% savings, which is very, very close to 10 times more usable storage just for turning it on. So previously, data deduplication was available in Windows Server, but you could only use it with the NTFS file system. And Microsoft's recommended file system for hyper-converged infrastructure is REFS, the resilient file system. It's essentially, we were having a hard time making one file system that simultaneously addressed the needs of small Windows 10 laptops to compete with Chromebooks, and then on the other end, the file system to power our server infrastructure and to power Azure. And so on the one hand, you have NTFS, but for things like hyper-converged infrastructure, our recommendation is REFS. And there are some good reasons for that. For one thing, it has some pretty deep integration with storage spaces. So it'll do things like detect and correct single bit flip errors and corruptions inline. And so it'll try to read a file, it'll detect that the checksum doesn't match, and it will go look at a different copy of that file from storage spaces, correct it, and then return the read. And as an application or a user, you don't even know that this happened, but that's the kind of integration between REFS and storage spaces that's really valuable. And there are also integrations between REFS and Hyper-V if the files that you're storing are VHD files for Hyper-V. And so, for example, if you try to expand a VHDX file, we have this great demo where if you do it on NTFS, how long it takes is proportional to the size, because it's actually writing out zeros. And if you ask for 100 gigs worth of zeros, that takes some number of minutes. And if you ask for 200 gigs of zeros, it takes twice as long. And with REFS, it's instantaneous, because there's this integration where some common VHD operations like that, such as, for example, merging checkpoints, Hyper-V will just sort of have a secret little handshake with REFS, and it happens instantly as just a metadata operation. So there are a lot of reasons we recommend REFS for hyper-converged infrastructure. And finally, in Windows Server 2019, you can use deduplication and compression together with REFS. And it's also very easy to turn on. So in the Windows Admin Center UI that I showed earlier, you literally click a rocker switch. It's like putting your phone on airplane mode, and then you're off and running. There's not any complicated decisions that you have to make. You just click a button and come back the next day and see how much you saved. Question, yes?
Is a tool available with that you can evaluate the deduplication potential for existing S3 cluster before you enable this?
So the question was, is there tooling available to evaluate how much you would save, but without actually turning it on? Which is a really good question. I believe the answer is yes, but it's not available in Windows Admin Center. And I know Dave is giving a talk, I think it's tomorrow, all about data deduplication, where I believe he demos that tool, which is a great question. Good question. So I've talked a lot about dedupe here, but it's not just about deduplication and compression, right? Making storage spaces direct an enterprise-grade storage platform is about having all of the features that organizations expect, whether that's encryption or deduplication and compression or integrity checksums or lots of different software resiliency modes like RAID 1 and RAID 5 and RAID 6, having caching and tiering. And we're finally getting to a place now after several versions where our storage spaces software stack really does have all of those features that an organization expects from enterprise-grade storage, which feels really great for me as a member of the team. Okay, now even with deduplication and compression, sometimes you just need a lot of raw storage capacity. In Windows Server 2016, the maximum scale of a storage pool was 1 petabyte. That was how much data you could have raw in one cluster. In Windows Server 2019, we've increased the scale quite significantly to actually 4 petabytes of storage in a single storage pool in a single cluster. To put in perspective how big 4 petabytes is, because it's kind of like this abstract quantity, that's actually enough space to store all of Wikipedia in every language with the complete edit history, uncompressed, 50 times in a single cluster. And if that's not enough, there's actually technology in Windows Server 2019 that lets you scale even further. And I'll talk about that in just a sec. Now, we did a demonstration at Microsoft Ignite to show that this was actually possible. So we partnered with our friends from Quanta Cloud Technology, or QCT, and we used their very dense 4U systems, 8 of them, to build essentially one rack of solid hard drives. And that system was about 3.6 petabytes raw, so very close to 4 petabytes. And this was, we think, the largest storage spaces direct cluster ever outside of a public cloud. So just to sort of show that it is actually possible, all of that hardware can be assembled in one room, and it does turn on. Now, I mentioned earlier that if you want to go even beyond 4 petabytes, you can. And actually, there's another limit this gets you around, which is if you want to go beyond 16 servers in a cluster in Windows Server 2019, finally now, you can. So in Windows Server 2012 or 16, you could take up to 8 or 16 servers and make them into a cluster. In Windows Server 2019, you can actually take a cluster like that and encapsulate it into something called a cluster set. And you probably guessed it, the reason you would do this is so that you can add multiple clusters into that cluster set. The key piece of technology here is some new additions to the server message block, or SMB protocol, including an infrastructure scale-out file server role and a technology called SMB loopback. And what that allows you to do is you can run a virtual machine on one of the clusters in the cluster set, and then even though its storage is in the same cluster, right? So in this case, the virtual machine is in cluster 2, its storage is also in cluster 2, you can actually take it and seamlessly live migrate it over to a different cluster within the cluster set. And even though its storage stays behind, it maintains seamless access to its storage because of this unified namespace for the cluster set. So this allows you to build much larger fabrics out of smaller individual clusters. And so you can do, for example, 4 clusters of 8 or 8 clusters of 8. And in fact, as part of our regular testing at Microsoft, we've actually pushed this technology up to over 1,000 servers in a fabric with a single unified namespace. So this allows you to go much beyond even the several petabytes that I showed earlier. Now, with each version of Windows Server, we try to make sure the numbers get bigger. And it's not just about capacity, it's also about performance. And so we did a demonstration at Microsoft Ignite showing Intel Optane DC persistent memory. And that's just one example of how Windows Server is on the leading edge of x86 hardware innovation. We have a very large team whose primary focus is on making sure that whatever the next hardware is that's coming out, whether it's the latest Intel Xeon Scalable processors, or remote direct memory access networking, or any other type of hardware innovation across compute or storage or networking, we want to make sure that Windows Server is among the first operating systems and among the first hypervisors to fully support all of that new hardware. And like I said, my favorite example this year is Intel Optane DC persistent memory. So at Microsoft Ignite, some of you may have seen this, we did a demonstration together with our friends from Intel where we built a 12-server cluster running hyper-converged infrastructure with Windows Server 2019. And each of these servers is packed with some Intel Optane DC persistent memory, which Storage Spaces Direct used for caching. And using this system, we were actually able to set a new industry record for performance from a single hyper-converged cluster, with over 13.5 million 4K random IOPS, which is more than 1 million IOPS per server from this 12-server cluster. Now, performance like that is not just about hardware light-up, though. That's a big part of it. These hardware innovations are a really big deal. They are a great reason to modernize. But there's also the other side of the equation, which is the software, right? So in Windows Server 2019, there are optimizations across the storage and networking stacks. Way more than I can mention right now, way too many to mention, but just to give a few examples. The TCP and UDP performance in Windows Server 2019 has nearly doubled the throughput on both send and receive paths. We also introduced something called receive-side coalescing in the Hyper-V virtual switch. So for traffic flowing through the Hyper-V virtual switch, if you look in the upper right there, between Windows Server 2016, which is what you see, and Windows Server 2019, you now get much higher throughput with like almost half as much CPU usage. And there are many more optimizations like this all throughout the compute and storage and networking stacks in Windows Server 2019. To give an example from the storage side, we have a technology called mirror accelerated parity. It's a way that you can actually create a storage space's volume that partly uses mirror resiliency, and then primarily uses parity or erasure coding resiliency, so that you sort of get the best of both. You get the fast performance from mirror, but eventually, and not inline, the data is rotated into parity, and then you can get greater capacity efficiency. If you take Windows Server 2016 as the baseline for how quickly that technology can actually work, how quickly it can receive data and then rotate it into the parity portion, it's actually doubled between Windows Server 2016 and 2019. Just as the result of tons of compounding little optimizations that the team has been making, clever write caches, clever write-ahead logs, cleverly chosen sets of edge cases where we bypass them. All of those things really do add up to a significant increase in performance. Now, with all that performance, you're going to want to be able to see it. And luckily, in Windows Server 2019, that's easier than ever with hyper-converged infrastructure, thanks to a new feature called built-in performance history. What it allows you to do is get data from an hour ago or from yesterday or from last week without having to set up any kind of complicated or third-party monitoring solution yourself. So if anyone here has deployed a hyper-converged cluster with Windows Server 2019, one of the things you'll notice is there's a volume that gets created for you as soon as you set it up called cluster performance history. It's very small, but you can see it in all the usual graphical tools. It just shows up cluster performance history. What's going on there is the hyper-converged cluster itself is actually collecting over 50 important performance counters, things like processor usage or memory usage, network activity, including RDMA, storage, throughput, IOPS, and latency, about 50, it's actually closer to 70, performance counters that we believe are useful for understanding the behavior of an HCI system are automatically being collected and stored into this small volume that we provision for ourselves. And that data is actually, there's a sample every 10 seconds for each data point, and then they're gradually thinned out over time. We actually keep some samples up to a year. So you can get sort of long-term trending on things like your CPU usage and your memory usage. And all of that data is available in Windows Admin Center, as well as, of course, in PowerShell for scripting. So if you manage a Windows Server 2019 HCI cluster in Windows Admin Center, one of the things you'll notice is all of the charts have this time range picker, where by default you're seeing data from the last hour, but you can see data from the last week or month or even last year as well. And then in PowerShell, there's some really fun stuff you can do, because now all of this data is being collected from the moment you create your cluster. Now, to be clear, it's being collected locally. We're not sending it home to Microsoft. It's just being stored in a little database there for you so that when you load the UI, we can draw these nice charts. But because it's all scriptable in PowerShell, you can actually do some pretty surprising things with surprisingly little code. So, for example, one question that comes up from time to time when we're doing performance troubleshooting ourselves is, did CPU ever spike at some point? Like, was there something, did Defender kick up or something that caused CPU to spike? And with just this fairly modest block of PowerShell, you can actually produce for yourself a report now that looks like this, that says, hey, for each of the servers in my cluster, here's the minimum CPU that was observed over the last 1 week. Here's the maximum for each of them. And you can see right away that server 2 clearly spiked to almost 100%. But this is where it gets really fun. You can actually see how many hours was the server over 25% CPU usage. How many hours of the week was it over 50% usage or over 75% usage? And so what this shows us is that none of the other 3 servers were ever over 25%, ever. 0 hours last week, right? And again, I didn't set up any fancy monitoring. I didn't start collecting this information. It's being collected all the time, and now you can script against it in PowerShell and get some pretty interesting insights. And this is all just the out-of-box behavior by default. You don't need to set anything up or install anything or configure anything. You just create a hyper-converged cluster, and this starts happening. By the way, we have that scripting sample and about a half dozen other kind of fun ones in our documentation. So you can do things like find network activity that's interesting, find drives that are slow, things like that. OK, now with Storage Spaces Direct, HCI, Azure Stack HCI, call it whatever you'd like, you can deploy anywhere from 2 to 16 nodes. And you can absolutely start small and then add nodes one at a time to scale as the needs of your organization grow. Now, when we first created this technology, we actually thought that the most common thing was going to be larger deployments, like 4 or 8 or 12 servers. But what our telemetry shows us is that actually you are more often deploying it at the edge in smaller remote offices and branch offices, taking advantage of the fact that the minimum footprint is actually very small. All you need is like 2 nodes with 4 drives each. You don't even need an Ethernet switch necessarily. You can connect them just back to back with a crossover cable if you'd like. And one of the things that we were sort of realizing was a limitation for those kinds of small 2-server clusters was their ability to tolerate multiple failures. In fact, like a year ago, there was no solution on the market from any vendor that could tolerate multiple simultaneous storage failures with just 2 nodes. Nobody had an answer for this. And the reason was, whether you're talking about Storage Spaces Direct or any competing technology, with a 2-node cluster, resiliency was always accomplished using 2-way mirroring, meaning essentially we keep one copy of the data on one server and a whole other copy on the other server. And that means you can tolerate a drive failure, no problem. You can have a node go down, also totally fine, no problem. But if both of them happened at the same time, like if you were restarting a node and then you had a drive fail or vice versa, you would always have an outage because your VMs would lose access to their storage and they would go offline. And this was not great. And so we took inspiration from something called RAID 51, or RAID 5+1. It's actually kind of an old technique. It's an example of what's known as a nested RAID level. And what RAID 5+1 does is it says, OK, within one of the servers, I'm going to do parity, like a RAID 5 style of resiliency. And then I'm actually going to mirror that over to the other side, meaning I'll get RAID 5 on the other server as well. And now, in Windows Server 2019, storage spaces can do nested resiliency like this. Of course, you don't need a RAID card. You don't need any special hardware. You just need some drives in each of the servers. But Storage Spaces Direct can actually do this. And what that means is with nested resiliency on a 2-server cluster, you can tolerate multiple simultaneous failures. And so if you have, for example, 2 drive failures at the same time, it's no problem. Even if you have a drive failure and one of the servers goes down, that's also fine. Storage Spaces Direct will survive, all of your volumes will remain accessible, all of your virtual machines will keep running. So we're seeing a lot of adoption, a lot of interest in these kinds of smaller 2-node deployments, especially for branch offices and remote offices. And so one of the things you'll see is, if you just walk down the hallway outside this room, is there are a lot of great hardware solutions available for this exact use case. And so again, folks like DataOn or Thomas Kren or SecureGuard, just to pick on a few who are sponsoring this conference, you'll see that they have, or Lenovo, I shouldn't forget them, they have solutions in many cases that you can actually get your hands on outside for this kind of use case. Now, an important part of the operation of any cluster is keeping the Windows servers that comprise the cluster fully patched and up to date. And it's never been easier to do that than with cluster-aware updating for hyper-converged infrastructure. Some of you, I'm sure, are aware, but some of you maybe are not. Cluster-aware updating is a technology in Windows Server that essentially takes the pause, drain, install the updates, and then resume. It takes that workflow and repeats it automatically across all the servers in a failover cluster. And so this can really make it much less tedious to roll out an update across a large cluster. Rather than repeating that yourself, it provides the orchestration for you. It's even better in Windows Server 2019 now, thanks to 2 big integrations in particular that I think make a big difference. The first one is it now integrates with storage spaces. So before it shuts down any server, it will check to confirm that all of the storage is healthy and that resynchronization is completed, and it will just wait as long as needed for resync to complete if it's not, which means it will no longer do things like timeout if you have a lot of storage, which it used to do with Windows Server 2016. The second integration is even more clever. It now integrates deeply with Windows Update. So before pausing a server and then restarting it just to apply an update, it'll actually check if the update requires that first. And for updates like Windows Defender definition updates, which don't require you to restart, it won't even pause the cluster node, which really minimizes the amount of disruption that virtual machines experience on the cluster. There's also a new user interface available for cluster-aware updating in Windows Admin Center. If you're familiar with the Windows Update tool, you'll see that this looks very, very familiar to that. The whole idea was if you know how to apply Windows updates using Windows Admin Center to a server, then you know how to apply them to a cluster. You go, you see a list of your machines, you click check for updates, it shows you the updates available for each of the servers in the cluster, and then you just hit apply and go get a sandwich. And it orchestrates everything else for you. All right, now I've been talking about hyper-converged infrastructure for more than half an hour, and I haven't even really specifically talked about Hyper-V yet. So what's new in Hyper-V, right? Well, one of the huge focuses for our engineering team has been around a technology called shielded VMs. Who's heard of shielded VMs before? OK, awesome. So if you've looked at shielded VMs, then you know that there were a handful of small limitations in Windows Server 2016, things that just made it a little bit easier, a little bit less easy to use than a regular VM, for example. Many of those are significantly improved in Windows Server 2019. To give one example, it used to be that if you lost network connectivity to your shielded virtual machine, well, shit, you couldn't get to it. In Windows Server 2019, you can now still connect to it using the Hyper-V Connect, VM console, as well as using PowerShell Direct. So you have 2 ways to, from the host, securely access a shielded VM, even if you lose network connectivity. You can also now run Linux inside of shielded virtual machines. So in Windows Server 2016, that was limited to just Windows guests. We now have official support and actually a co-engineering effort to make this happen with our friends at Ubuntu, at Red Hat, and at SUSE. So you can run those 3 Linux distributions inside of shielded virtual machines as well. And there are a lot of other improvements. In fact, Thomas showed a few of them in his previous session. Things like being able to actually boot a shielded VM in offline mode if your branch office has actually lost internet connectivity. Things that just make it less brittle and something that's about roughly as easy as a regular virtual machine to use on a day-to-day basis. Now, regardless of whether you're using shielded virtual machines or not, it is important to protect your hypervisor hosts. And there's a significant change in Windows Server 2019 that I'd like to talk about. So in the last year or so, the Spectre and Meltdown vulnerabilities, I think, have shined a very bright light on side channel attacks, which is a category of attacks that I think most of us had not heard of or not spent much time thinking about before. Hyper-V has multiple scheduler types. Who has heard of Hyper-V scheduler types before? OK. Oh, that's the future is good. I was about a third of the room. That's good. In Windows Server 2016, Hyper-V used a scheduler type, which was actually the only one available back at the time, that we are now calling the classic scheduler. And what the classic scheduler does is it provides essentially a fair share preemptive round-robin way of assigning logical processors onto physical cores. It's essentially at random. There's a new scheduler type in Windows Server 2019 for Hyper-V called the core scheduler. And what it does is it actually further constrains the placement of logical processors so that multiple logical processors belonging to the same VM are on the same set of physical cores. So that even if that VM somehow tries to exploit a side channel attack, even one that we haven't thought of before, to look at other logical processors running on those cores, there will not be another VM's logical processors. It'll just be looking at itself. And so that's a very good reason, I think, to be using the core scheduler. And as a result, Microsoft has actually made it the default on Windows Server 2019. So if you deploy Windows Server 2019 as a Hyper-V host, there's nothing that you need to do. The core scheduler is just, it's there, it's on by default. We did want to make the core scheduler available in more places, though. So it is also available with Windows Server 2016. There are a handful of caveats, and it's not the default behavior, but we did backport it in a cumulative update last fall. And so if you're using Windows Admin Center, you'll see in the Hyper-V settings, there's a new radio button called Scheduler Type. And if you have a fully patched Windows Server 2016, you can actually change it from Classic to Core if you want. And then again, with Windows Server 2019, it's the default behavior. OK, the last thing, number 10 out of our list of top 10 things that are new for hyper-converged infrastructure. And this one is not 100% on-prem like the first 9 were. This one is more of a hybrid feature. When we talk to customers, which is a big part of my job, right, is to go out, and I'm hoping some of you will come up and talk after, or we can talk outside. When we talk with customers, what we're seeing is there are 2 distinct approaches that organizations are taking to hybrid infrastructure. Everyone agrees that they're going to be using some combination of public cloud infrastructure and on-premises infrastructure for the foreseeable future. But there are 2 different ways of going about that. One is to start from a cloud approach and then to bring those consistent cloud services on premises. And that's something that Azure Stack has been offering for a couple of years now, and it's actually unique in the market. There's no competitor for Azure Stack. There are some announced things, but in terms of in-market products, Azure Stack is the only way to do that today. There is another way, though, of thinking about hybrid, and that is to actually start with what you have. Start on premises, and then connect up to public cloud services if it's useful. Find examples of services that maybe can actually make on-prem better and connect to those when it makes sense. And that's something that we're very interested in with Azure Stack HCI, is to say, are there examples where connecting to a cloud service would actually make an HCI cluster better? And I think there are some examples, especially when we talk about those smaller remote office and branch office deployments. So, for example, if you're deploying a cluster, like a 2-node cluster in a branch office, presumably you care about high availability and fault tolerance, right? That's why you're deploying an HCI cluster in the first place. But it may not be cost-effective to have backup infrastructure at that branch office. And so one of the things that Windows Admin Center makes very easy is connecting your HCI cluster in a branch office to Azure Site Recovery. And you'll see it's actually integrated directly into the virtual machines list that I showed earlier. And so when you're looking at all the VMs running on your HCI cluster, under the list of actions, there's one called Protect. And with just a very couple of clicks, you can actually back that virtual machine up to Azure Site Recovery. So normally, day to day, hopefully every day, it's running on premises in your branch office. But if something terrible happens, you can actually run that virtual machine in Azure instead because it's been backed up already for you. Another example is connecting to Azure Monitor. If you have a branch office, then you probably have many branch offices. That's why you call them branch offices. And each of those branch offices may not have dedicated IT personnel on site, which means you want to be able to monitor for problems in those branch offices in a central way. And a really easy way to do that without any kind of fancy monitoring infrastructure of your own is with Azure Monitor. So you can take your HCI clusters in each of the branch offices, install the Azure Monitor agent, and then if something goes wrong, like if a node goes down, or if you're running out of storage capacity, or even if you just have a drive failure, for example, Azure Monitor can actually send you an email alert or an SMS alert, or there's actually hundreds of other things that you can set it up to do using any of the integrations available through Azure. It can send you a Teams message. It can execute some code for you to remediate if it was something that could be remediated. And just to pop it open, you'll see you can get all of the details of what it is that went wrong available even when you're not at your desk, wherever you are. So you can monitor all of those different branch offices in a central way. OK, am I out of time yet? Oh, almost. But we did make it. We covered 10 things that are new for hyper-converged infrastructure in about 10 minutes. So if you're interested in getting started today, you can. You can find solutions from your preferred hardware vendor for hyper-converged infrastructure by going to microsoft.com/HCI. And then we also have URLs here for where you can find Windows Server 2019, find Windows Admin Center, and learn more about getting started connecting to some of these hybrid services that can actually make on-prem better. Just to show you what that microsoft.com/HCI URL looks like, we actually have a really nice catalog that allows you to not only view but also kind of browse and filter all of the available hardware solutions from our over 15 partners. There's actually over 75 solutions available already. So just to show you, if you, in your browser, go to microsoft.com/HCI, that'll take you to a marketing page, which means the first thing you should do is click to navigate beyond it. Click the big blue button called Catalog, and that'll take you to this page where you get this store-style experience where directly on Microsoft.com you can actually browse the hardware that's available. And so you can filter, say you want something from HP that's all flash with iWarp available in Europe, and you can see the solutions that are available, and you can actually click them and it'll deep link you into the exact page on the partner website where you can learn more, browse the specific details, and contact their sales team to get started. And of those 15 or so partners, there's actually 8 who are sponsors of this conference, which means they are physically here, they have people here, and you should go talk with them because they're very nice people. OK, I know I'm the only thing standing between you and lunch, so with that, I will conclude. Thank you very much.